Sounds like Woodstock. Okay, here we go. For some people, this is their favorite unit in trigonometry, okay? Favorite unit in trigonometry. It deals with really just solving triangles. The deal is that there's a lot of triangles that are not right triangles, meaning they don't have a right angle. They're called oblique triangles. So if we call this angle A, angle B, and angle C, you can see that this is a non-right triangle. The question is, how can we say something intelligent about it without trying to use SOHCAHTOA? For example, SOHCAHTOA does not work in this situation because it's not a right triangle. Also, a squared plus b squared is equal to c squared. That doesn't work because it's not, it's not a right triangle either. So let's try to say something interesting about it. I'll call this side A and this side B, and I'm going to make a right triangle by simply dropping down the height of the triangle itself. Call that H. Yes. Mr. Durban may have shown you some of this. I'm not sure. Definitely not. She doesn't know how to do trigonometry. I'm kidding. I'm just kidding. Sorry, being else like you're going to watch this anyway. Okay, yeah. No, it does not. So what we're going to do here is we're going to make a trigonometric ratio that does deal with the right angles, namely dealing with the opposite side and the hypotenuse. What has to do with the opposite side and the hypotenuse? Sine. I'm going to say sine of angle A is equal to what? Opposite, which is H divided by B. If I multiply both sides by B, I get B sine of A is equal to H. Yes, no? I'm going to do the same thing for angle B. I'm going to say the sine of angle B is equal to H over A. If I cross multiply, I get A times the sine of B is equal to H. What is interesting about those two expressions? They're both equal to H. And if they're both equal to H, then they're equal to each other. So B times the sine of angle A is equal to A times the sine of angle B. Some books actually write the law of sines in this fashion. I'm not going to do that. I'm going to simply divide both sides by AB. When I divide both sides by AB, I get sine of A over A, sine of B over B. And that turns into our law of sines. The sine of angle A divided by side A is equal to sine of angle B divided by side B, which is sine of angle C divided by side C. So really, if you have an angle on its opposite side, you can make this work out. Bilake, you got a question? Okay. So, again, it requires that you have an angle and its opposite side. So I'm going to draw this first triangle. Angle A is 42 degrees, calls B is 80 degrees, and then side A is 10. And today we want to work on solving these triangles. Angle A, B, and C, side A, B, and C. I want to find all 6 parts. I'm going to write down my knowns. I know that angle A is 42 degrees, and I know that angle B is 80 degrees. I know side A is 10. Obviously, what's the easiest part to figure out at this point? Angle C, because all the angles add to 180 degrees. And so if you do that, you can figure out that this is 58 degrees. Now it's important for us to pause and for you to think critically about this type of a problem. Okay, so we can get some confusions out of the way and some presumptions. Okay? First of all, if you know 2 angles, you're going to know the third angle. True or false? True. Now, we want to start classifying this type of triangle. So I want you to turn to the very last page of your notes. If you'd like to, you can rip that page off. That is the sheet of notes that you'll get for the test. I applaud you. All the other classes, or the other two classes, they almost screamed in agony when they saw this. They saw things like angle, 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 and angle, side angle. They're like, we never understood it. It was totally confusing and impossible. So good for you for not having that reaction, okay? So let's clear it up and look at it very, very simple, all right? Angle, angle, angle worked for similarity, but it did not work for triangle congruence. Why? Because I can have a 60, 60, 60 like this, or like this. They're similar, but they're not congruent because they're not the same size, right? So if you're given three angles, is there any way to find out the missing sides? No way. So that would be a no solution triangle. For this triangle, I want us to look at angle, angle, side, and angle, side, angle. First of all, if we're given two angles, are we going to know the third angle? Yeah. So really these both state that you have three angles and one side. But let's talk about the way that this is written. As we look at the problem that we have right now, you can see that I'm given two angles and one side. Is this an angle, angle, side, or an angle, side, angle? How come? You guys are so confident. The other two classes were not. We had to really talk about it. Okay, I like what you guys are saying, but I want to make sure that we quantify that and understand a little bit better. Look at where I start. If I start at angle A and I go this direction, then I get an angle, a side, and an angle, right? Now you guys were all going angle, angle, side. Let me tell you just a little bit more about why we know it's angle, angle, side. What is the side? I'll call this, obviously this is angle C, this is side B, side A, side C. Which of the sides, A, B, or C, is shared with both angle A and angle B? C. So if you were given side C, then it would be angle, side, angle because it's shared with the two angles. Do you see that? It helps make up the two angles. Does 10 make up the 80-degree angle? Yes. Does it make up the 42-degree angle? It has no part to it, so therefore this is an angle, angle, side triangle. You understand that? Now, it turns out for us that it doesn't matter whether it's angle, angle, side, or angle, side, angle. Either way, there's just one solution that we will find using the law of sines. I made this decision tree up a number of years ago when students could not figure out how to determine the number of solutions of a triangle. I think that this is very helpful. Every student should learn how to read this. This is what you get to use on the test to help you through. Trust me, you're going to want to know it. All right? So let's solve the triangle. Law of sines, here we go. I need an angle and its opposite side. So sine of 42 over 10 is equal to sine of 80 over b. I cross multiply. 10 sine of 80 is equal to b sine of 42. I solve by dividing both sides by the sine of 42. I want you to at least write out the initial ratio. Many of you will then immediately go to your calculator and you'll be able to determine it without showing the rest of your work. But I need to see the initial one so I know that you're not simply just writing down my work. Should I be in radians or degrees on my calculator? Degrees. So I type it in. I have 10 sine of 80 divided by sine of 42. And I get 14.72. We're going to round to the nearest hundredth. Is everybody okay with that first step? What would I do to find C? Can I use a Pythagorean theorem? No, because it's not a right triangle. So I set it up again. Sine of 42 over 10 equals sine of what? C is 58 over C. Now watch what happens when I cross multiply. I again get 10 sine of 58 is equal to c sine of 42, and I divide by the sine of 42. That looks almost identical to what I had in my calculator earlier, didn't it? So I'm going to show you how to save some time, folks, because we all want to save time, right? Time is important. That's identical to what I have right here, except instead of an 80, I have a, so I'll go second, enter, and that brings up the previous entry. I know some of you with your fancy dancy calculators are able to go back. I can't do that. I have to go second entry. I go back, I change that 80 to a 58, and I press enter, I get 1267. Everybody okay with that? Again, I just want to help save you time. So everybody okay with that first example? Okay. Your enthusiasm is spilling forth. I don't know if we'll be able to control it. My apology, I brought up an old section of notes. You're going to have to change your problem as well. It says angle B is what, 12 degrees? And then it says side B is 4. Make it 14. And then side A we'll leave as 10. Sorry about that. So I have angle B is 12 degrees. I have side B is 14. And I have side A is 10. Good. All right. What makes this problem different than the previous one we looked at? You have two sides. Now, is this a side-side angle, or is this a side angle side? Which one is it? Side-side angle. Look at my two sides. If I was given angle C, that would be the angle between the two sides, and we would choose side angle side. Now, some of you guys recognize this, that if I write it backwards, I get donkey, right? So you know that creates a big problem for us. It sure does. And so what we have to do is we have to go to our flow chart, our decision tree, and recognize we have a side-side angle. We go down, and it says, is the side opposite the angle longer than the other given side, or is the side opposite the angle shorter than the other given side? Yeah, side opposite the angle is longer than the other given side. That will be all the triangles you get today that fall in that category. Okay, if you get a side-side angle, all of them will end up being longer than the other given side. You can be confident that there's just one solution. Tomorrow we're going to investigate where there's not just one solution. There might be two or none. Okay, and so that's what we do tomorrow because we know that side-side angle creates an issue. So let's go through it. I set this up. The sine of 12 divided by what? 14 equals the sine of, not B, A over, if I multiply both sides by 10, I get 10 sine of 12 over 14 equals the sine of A. I'm going to create a decimal out of that. That's how they'd leave the answer on the AP, or I'm sorry, the ACT, divided by 14, and I get, okay, so you guys just got out of a unit where we graph sine and cosine. What's the biggest value that sine can be? 1. What's the smallest it could be? -1. So sine has to be between 1 and -1. Does that fit? Yeah. So we second sine inverse, and that will allow us to find out what the angle is. And if I press second negative sign, that brings up that answer, and I get 8.54. Yep, so the way that you solve for the angle is you go second sign instead of sine. We talked about that when solving right triangles. So we get 8.54 degrees. What? Oh, now what do I do? Go away. There you go. Don't do that. Okay. Now what? Yeah, I could get the angle, no problem. I'm just going to go 180 minus 12 minus 8.54, 159.46. And then how am I going to find side C? Yep, law of sines. Sine of 12 over 14 equals the sine of 159.46 all over, C. I get 2363. Wouldn't it be nice if we could check our answers? Here's one way you can do it. Smallest angle, smallest side. So if A has the smallest angle, side A should be the smallest side. Biggest angle, biggest side. We verify that at least it's reasonable. Okay? All right, I'll hand out your assignment. We'll do a couple problems together. Okay, let's look at example 1. Fill out the pieces we know. We know that angle B is 32. We know angle A is 85. And we know side B is 20. What can you obviously figure out right away? What is angle C? $63. Okay. So what kind of triangle am I given here? Angle, angle, side. So if we look at our decision tree, we know we just have one solution. I use the law of cosines. Sine of what? 32 over 20 equals the sine of 85 over A. See if you can now find side A and then move on to find side C. I'll put it up here on the board so you can check to see if you're correct. Why'd you do that? Jake made an excellent point. These can be quite straightforward. You want to make sure that you're very quick at them and efficient at them, because we're going to be, trying some more challenging stuff as we move forward. I got 3760 and 3363 is what I came up with. Make sure you get the same answer as you work through. Are we all good? Okay, let's try a different one. All the ones on the left-hand side, folks, you'll be solving for a side first. All the ones on the right-hand side, you'll be solving for an angle first. Here, I draw it out. I have angle A, B, and C, 40 degrees, 10, and C is 7. So I have 40, 10, and 7. So you guys tell me, okay? What kind of triangle is this? Angle side side or side side angle? Very good. It's the donkey. And so as you move down, is the side opposite the angle longer or shorter than the other given side? It is longer. Whoop, wrong one. Still longer, but let's see. Where are we? There we go. 10 is longer than 7. So I can be confident there's just one solution. Sine of 40 divided by 10 equals sine of C divided by 7. If I multiply both sides by 7, 7 sine of 40 divided by 10. Can sine equal a value like that? Yep. Let's sine inverse. And I get 2674. So that's C. What can I now do? Yep, 180 minus that answer, minus 40. Excuse me, 113.26. Can we now find side B? Yeah, we can. Sine of 40 over 10 is equal to sine of 20. I'm sorry. Sine of 113.26 over B. $14.29. I checked to validate that, in fact, B is the largest angle and it has the largest side. Now I feel pretty good about my work. Okay. So the practice is in front of you. You want to be efficient at this and quick at this because, trust me, we're going to move on to more challenging stuff as we move forward. So this is a foundational skill. Have a great day. Good work today, you guys.